So here we are, day 3 on this deer project. Um, I knew this was going to be a big project. A lot of people have asked me since I started doing this, why that skull? Why that deer skull? I mean, of all the skulls that we've scanned in here, um, probably the only one that's more complicated in terms of managing that amount of data was the cow, because it's really big as well. Um, and the reason I did that is because I want the people that are watching these videos that are hopefully going to come into the lab and use the scanner for things, understand that every project brings its own complexity to it, brings its own set of challenges and things to overcome. And the deer skull is, um, it's an interesting subject in that it's really big, so it provides a technical challenge in terms of resource management. It has a lot of complex geometry. It has enough simple geometry that you can feel productive with it, and it's not so terribly frustrating. But it is challenging in terms of being able to get all of the surfaces and the glossy surfaces and the tiny little nooks and crannies and all the little cavities, and understand that there's some things that you're just never going to get. So um, I went ahead and I finished scanning in the antlers. The second antler went just like the first one. And the biggest challenge with the antlers is positioning them so that you can get a good scan and keep tracking while you're getting down to the very ends of the tips. The isolated narrow geometry is a challenging surface to scan as well. And so after I got that scanned in, I did the same sort of registration process that I did with the rest of the skull. Trimmed out all the excess data, which with the antlers was actually quite a lot. I had to roll the antlers around on that platform so they always have something to register against. Trim all that out, align it all up, um, do the regular registration. The rough serial registration was needed a few times, then the global registration, outlier removals, and then I did a sharp fusion. Normally I do a 0.1 resolution because that's going to give me the best details. Below 0.1 you sort of reach a point of diminished returns where the polygon count gets really high but the detail that you see doesn't really get any better. So I did this one at 0.15 because I knew it was going to be a lot of polygons, and I figured 15% of a millimeter is still pretty damn small. It's close enough. You still see a lot of detail in the finished mesh, and this skull came out to what is that? I have to count the digits. 22 million and some change polygons, which is a lot of polygons. The other thing that I did, started up last night and let it run because this process can take a while, is I did a mesh simplification down here. So I went, as soon as I did my global registration and my outlier removal, I did a sharp fusion, and then a mesh simplification. Another thing that you could do, the small objects filter runs through really quick and deletes any small floating bodies. If your scan is clean, outlier removal is probably going to get rid of all the little bits of garbage data. But say there's a bit of garbage data or maybe a cluster of points that it doesn't really recognize as outliers. Sometimes it interprets it as being another object in the scene, and it will mesh. It'll either try to incorporate that into the mesh or make it another object itself. The small objects filter quickly goes through and finds those free floating bodies and removes those. If you also get a piece of garbage mesh that sort of protrudes, I don't really see any on here yet. If you do your scan well, or if your scan comes out well, sometimes it's not always a function of the operator skill, then you shouldn't have too many foreign protuberances coming out. I mean, I'm pretty happy with the way this turned out. I even got like the little chip that was in the corner of the antler up here, and you can see the texture in the surface of the antler, all these little knobs, and this is just a beautiful device. I'm thrilled by what we're able to quickly capture and bring into the computer. Because a year ago, modeling this by hand would have been just impossible. I could have come up with something that looks like a deer skull, but I could not have captured a actual skull in all of its details like this. So this is going to be a big thing for the biology department. Even if we get something really rare, something we only have our hands on for, a couple hours, we can capture enough data that we can reasonably build a good mesh out of it. And, it doesn't have to stay with us very long, and we can keep it, and we can reproduce it, and we can do things with it digitally. So this simplified mesh, and I'm going to rename this because, also, I should tell you, if I have, say, this high polygon count mesh here, and I have it selected, and I go over here and I hit mesh simplification, it's going to simplify this mesh. I wanted to retain the 22 million polygon model. So what I did was I right-click on it and go to duplicate scans, and it'll create another duplicate of it, and that duplicate is what I simplified. So I have another one there. But I don't need two that big, so I'm getting rid of one of you. So this mesh has I looked at the wrong one. Turn off the big one, turn on the little one, and the project info here. Okay, 3.5 million, 3.5 million polygons, which is a much more manageable number. Still can't get over that 3.5 million polygons is manageable. But this machine is just tossing it around like it's no big deal. Speaking of resources, I had a change of plans over the course of the project. I know initially I said that I was going to do the antlers as one project, the skull as a separate project, and then merge the finished meshes together. That is a really great process because at the end it allows me to work with two big chunks of data, but I don't have to deal with all the gigabytes and gigabytes of raw data that goes into building those meshes. I had to have a change of plans because I realized that I wanted to texture this thing. That is a great process if I have a really big mesh that I want to make an STL file out of, and an STL file is what we need to 3D print the thing. If I'm going to 3D print it, right now with the current level of technology, I'm not much concerned with the textures. We only have one printer that can print in color, and it's not the kind of printer I would print this on. So I normally wouldn't be concerned with textures, but I do have plans to use this in a real-time application such as Unreal. In fact, I'll probably carry this video series forward through the process of converting this into something that we can load into 3D Studio, something that we can animate, and something we can import into either the Unreal or the Unity game engines. So that's where this guy's eventually going. He's going to become real-time and virtual. So this mesh is still a little big for a lot of purposes. This would be a beautiful thing to 3D print. The 3D printer could handle a mesh of 3.5 million polygons, and it would get a lot of these details. And this model would come out phenomenally. So that's one of the things I'm saving it for. This mesh is still a little high of a polygon count to texture. One other thing I want to point out, notice how it fills in the sinus cavity. It got in as far as the scanner could see, but it sort of sealed up the rest of the sinus cavity with a sort of blistered sort of material. That's what you're going to see anywhere that you have holes in the mesh. And sometimes this can protrude out. It almost looks like it's leaking out of the mesh. And there's a way to clean that up too, if you'd rather just lop that off. You can come over here to the editor button, and this tool called the defeature brush works just like the eraser. You mark out the regions you want to get rid of exactly the same way, except with defeature it removes the polygons from the mesh, so it operates on a mesh, and it leaves the mesh sealed. So it replaces, instead of making a hole in the mesh, it replaces the geometry you're getting rid of with a nice sealed over smooth effect. And then if that leaves you with some rough edges, you can hit the smooth brush here and sort of smooth that back out. But that's a pretty rare occurrence. the spider really does an amazing job of getting all the geometry. So I need to take this down to a lower polygon count mesh. So I'm going to right click on it and duplicate the scans. Now because I was going to texture this mesh, I had to load all of the data up, and it's a lot of data. You could pause the video if you want and add up all these numbers and see how many, I don't know, I'm guessing 20, 30 gigabytes of raw data that has to be loaded into memory and loaded into RAM while it processes this mesh. That was one of the things that I really underestimated when I was buying this equipment, was how much RAM this process would take. I wish I'd gotten 256 gigs of RAM would have done nice in this machine for this process. I could scan some really big things in. But what you could do to sort of manage your resources in your project if it starts getting really big is you can load and unload selected scans from memory. So in a sense, I am sort of breaking up into two projects. I did the skull down here, and I did all that, and I sort of processed that and, you know, had everything aligned and registrated and cleaned up and ready to go. And then you can unload scans. So I selected those scans and go to, well, the scans are already unloaded, so unload scans is not an option here. But I can unload the scans from RAM and free up that space in the computer if I'm not having to work with that data anymore. So I did that for the skull itself, then I did it for each of the antlers, loading and unloading different data sets so that the computer wouldn't have to work with everything. Although, to make a texture, I'm getting ready to have to unload the entire thing back up now. But I'm not quite ready to texture this yet. I have this duplicate of the 3.5 million polygon count scan, and I'm going to do a fast mesh simplification on it. Now, the good thing about fast mesh simplification is it allows me to give it an exact number of polygons to use. Right now I've got it set at 65,000 because that is the maximum size that a mesh can have in a game engine like Unreal or Unity. So that's usually the target number that I go for, is 65,000. But I'm thinking for this one I may go 120,000. I mean, Unity can still accept a mesh of 120,000 polygons, or even higher. It just has to break it up into different meshes of no more than 65,000 polygons when it imports it. And the engine does that automatically. I think we could probably afford 120,000. And then you hit apply. And this process would take a long time if this were the first thing that I'd done after generating the Sharp Fusion. You always want to do just the straight up mesh simplification before you do the fast mesh simplification. Your final model will come out looking much better. Fast mesh simplification works only on the number of polygons, so it takes all the polygons that you have and just sort of merges them together and starts cramming them together until it gets to the target number, which is great. But you lose a lot of your details. A lot of your smaller details are going to come out chunky or obfuscated or washed out completely. But if I do just a regular mesh simplification, it does more of an optimization on the mesh. So it goes through, it finds coplanar faces, takes those out. It takes a lot of the meshes out of areas where there's less detail, but it keeps it in the areas where there's a lot of detail. So if it finds an area up in here where it's got, and you can't see what I'm pointing at, if you find an area up in here that's got a lot of like bumps and ridges and stuff, it'll retain those polygons because it needs to retain the detail. But the areas down here where you have a nice gradual curve across the back of the skull, over here, a lot of those polygons are going to get taken out and replaced with bigger polygons. And apparently it found 19 million polygons that it could take out of this mesh. Um, so doing that first is going to make our 120,000 polygon mesh look a lot better as soon as this green line gets all the way to the end. And I'm running out of things to say while I'm waiting on it. Maybe we'll just look at this model some more. That's one of the things I do like about this. I can, even while it's thinking, it's like it's doing that processing on a different thread than it draws the graphics on. So I can, oh, there we go. It is done. And my mesh has been updated and simplified. Now you've noticed that it right off the bat, it looks a lot chunkier. You know, I don't see the texture of the surface anymore. I don't see a lot of the smaller details, but it retained much of it. The little features around here where you got the little, I'm not even sure what you call that, the alien looking ridges. It's a creepy thing, isn't it? With skulls. We're doing a lot of skulls these days. Next year is just going to be drones. But skulls are cool. So yeah, this is 120,000 polygons. So I've gone from 22 million down to 120,000 and still retain a lot of the quality and the texture of the original scan. The last thing that's left to do is hit it with a texture. So and you want to do this with a lower polygon count model. You definitely do not want to try to texture a mesh that has millions of polygons, where computers just aren't there yet. Maybe one day, but for now, texture your lowest resolution mesh and you'll be a lot happier. So I'm going to go through and scan, select the scans that I want to use for the textures. Let me look down these options real quick. Implant missing textures means it's going to try and deduce what color a piece of geometry needs to be if I'm trying to texture a surface that I missed during the scan. I usually just leave all this alone. The resultant texture size I like to set at 4096 by 4096. It's a reasonable size. It's still a really nice high resolution image. Of course, it offers much higher resolution images. And game engines like Unreal or Unity support texture image sizes up to 16,000 pixels on a side, so that's not unreasonable. I think I'll go with 8192 by 8192, so it'll be a nice square image. It's going to put the image together based on the texture data that I got from the previous scans, and then it's going to map that to this mesh, and it's going to do that as soon as I hit this apply button. And what it's asking me here, this is its subtle little way of saying that it's getting ready to save the project. Sometimes it saves automatically. It's a good idea to save frequently because there's nothing like the feeling of realizing that you've lost 15 gigabytes of scan data because you neglected to save. But when it saves however many gigabytes of data you have in here. So it can be a long process. But this is its way of saying, hey, I'm getting ready to save. You've deleted some stuff. Would you like them put back in the history so that if I want to go back past the save, I'll be able to recover these. And I'm usually figure that I deleted them for a reason, so I don't want them in the save file. So it's going to go through now. This process could actually take a while, so I'm going to let it finish saving, and then I'm going to let it build the textures, and then when we come back, we'll take a look at it. And we're back, and our model is now textured with the images that were captured during the scan. It hasn't been applied yet. We have a chance here to change some of the settings and sometimes it may take a second for you to see the result of the change, but you can modify the brightness, saturation, contrast. Usually I find all it takes is maybe a bump in one direction of the gamma correction, a bump in one direction of the brightness, and it comes out looking pretty much like what I scanned. The only thing left to do is hit apply, and now that texture is part of our finished mesh. And it did have to go back through and reload all of these scans. So it's right now the system is under a considerable bit of strain. But the only thing left to do with this now is to export this. Everything else we do with it from here on out we're going to do in 3D Studio Max. So I select the scan. Go to Export Mesh, not Export Scans. Export Scans is, that's what you would use if I have a set of data in one project and I need to move it over to another project. You have to export the data out of the project and then import the scans back into the project, or the other project. But I'm going to export a mesh. And I'm going to make a new folder for this. I'll call it Deer Skull 3 because it's the third deer skull I've scanned. And Artec Studio supports a fairly comprehensive array of 3D file formats. An STL file is what we would use if we were going to 3D print this critter. But we're going to a real-time application, so I like the Wavefront OBJ file format. It's easily recognizable by a lot of different game engines. 3D Studio Max works with it really well. But what I've noticed is that no matter what I have selected as the file type, you have to explicitly type in .obj, or Artec Studio will save it out as a PLY file, which a PLY file is still okay. That's its default export. 3D Studio Max can still read it in, and it'll come in with textures and everything, and that's fine. But if you want to work with the .obj file, then you have to explicitly type .obj. Hit save. Texture format JPEG is fine. JPEG or PNG. I wouldn't go with BMP bitmap for an 8,000 by 8,000 image. JPEG should be just fine. One thing to notice, if you look at the file sizes for these different fusions, so this sharp fusion here was my original relatively low polygon count model, and it's 82 megabytes. The textured version is over twice that size. That's all textured data. It's a so we actually have a lot more information size-wise from the textures than we do from the geometry itself. And if we get a really close look at this, you can see it really captured a lot of the detail. I mean, it's not perfect. I mean, the 22 million polygon version isn't perfect, but it is really close. Really, really close. Okay, so with our OBJ file being exported, we are done with the skull, done with Artec Studio for this part. And before I take this over to Max and show you what to do with it, I'm going to do another video here on scanning the jaw, and we'll go through the process of putting them together. Thanks for watching.